Okay, so last time we worked on this part where we get to find out all the points like this, but today we are going to work on a method to eliminate these points which lies outside the polygon defined by this spline. Now as you can see, I need to get rid of these points and I only need these points. So on these points I can spawn foliages, so crops, so whatever the things that I need to spawn inside this area defined by the polygon. So how do I determine if that point is inside this polygon? Well, for that we can use this theory. If a point is inside a polygon, when we draw a line from that point to the infinity, that means like this, if that line crosses the polygon an odd time, that means if the intersections of this line with the lines that creates this polygon is odd, if it is odd, that means that point is inside that polygon. If the number of intersections are even, that means that point is outside the polygon. You can draw any kind of a polygon you need, a closed shape you need, and test this theory. So I'm going to use that theory to identify the points inside this polygon. But for that we need to know a couple of other things as well. So how do we know if a line intersects another line? So for that there is another theory like this. First I need you to show what's an orientation is. So let me draw two lines like this. I'll call this one, it needs to be in a color, otherwise you can't see. P1, I'll call it P1. Let me make it a little smaller. Okay, and another, this point is Q1 and this one is P2 and this point is Q2. Okay, so when we take any 3 points, let me draw some points like this, and that point is if these 3 points are clockwise, if it take like this, no, consider this case. So if we consider P1, Q1 and P2, I need to have another color for this. Yeah, if we consider P1, Q1 and P2, from P1 to Q1 it is like this, and Q1 to P2 it is like this. So this is clockwise. If we consider P2, Q1 and Q2, it is like this, that is also clockwise. So if we consider another line, let's draw another line like this, then I'll name this one Q3 and P3. Now if we consider P1, let me change the color. Yeah, now if we consider P1, Q3 and P3, this is counterclockwise because it rotates in this way, opposite to the direction the clock rotates, not the clock, the hands in the clock. Okay, now this is the theory. If there are two lines that intersects, then the orientation of those two lines of the points, yeah, let me draw it as well. Okay, now let me draw another line. Now these two lines does intersect, so I'll name this one P1 and Q1, and this one P2 and Q2. So yeah, the theory is, if yeah, we have to consider the orientations of these combinations P1 Q1 P2 and P1 Q1 Q2 and P2 Q2 P1 and P2 Q2 Q1. So like this. In this case, these does intersect. So P1 Q1 P1 Q1 and P2 P1 Q1 and P2 are counterclockwise, and P1 Q1 and Q2 the orientation is clockwise. So the other case P2 Q2, right, that means P2 Q2 and P1, this is clockwise, and P2 Q2 P1, this is counterclockwise. So the theory is, if these two orientations, that means P1 Q1 and P2 orientation and the P1 Q1 and Q2 orientations is different, and also P2 Q2 P1 and P2 Q2 Q1 orientations are also different, then these lines does intersect. So there are a couple of other special cases as well like this, but we don't really go into that much of detail because it's okay to miss a point or two on this line for this case. But if you like, you can implement those conditions as well, but I will ignore those special cases for now. And yeah, so I'm gonna define this orientation function now. So like this. Let's define a new function. I'll call it orientation, and to get the orientation I need 3 points as input. All of them are vector. I'll call them P, Q and R. And I'll break all these 3 vectors to make it easier to do the calculations. Okay, now how to determine the orientation of these points. So for that we can use this piece of code. This value, using this value q dot y minus p dot y into r dot x minus q dot x. So using this piece of code, using this code, we can identify the orientation. So if the orientation 0, that means it is collinear. Collinear means those 3 points lies in a same line. So if we consider p1 q1, and let's add another point like p4 which is on this line, then p1, p4 and q1 is said to be collinear. Okay, so I'm going to implement this piece of code here in the blueprints like this. Qy minus py, qy minus qy minus py in, and the next thing is rx minus qx, rx minus qx. And the next thing is qx minus px. Let me add a simple comment here. This is qy minus py, and this is qx minus px. Next one is rx minus qx. Qx minus px. It should be like this. And rx minus qx. This is qx. Rx minus qx. Ry minus qy. That's all, right? Okay, now we need to get the multiplications of first two and then minus it from the second two. Okay, now based on the value, if that value is 0, that means collinear. Otherwise, if it is larger than 0, that means clockwise. Otherwise, it means counterclockwise. So I will return the values like this. A branch, if this one is equal to 0, if it is true, return. I need the output in integer type. Our return value is orientation. The return value is 0. That means these 3 points are collinear. I don't think I need an I here. Otherwise, let's do another branch. If this value is larger than 0, return 1. That means clockwise. Otherwise, return 2. That means counterclockwise. Okay. Now we need to implement this function do intersect. So when we give 3 points to this function, it can identify if those points, if the 2 lines created by these 4 points are either intersect or not. So let's create that function like this. To intersect, as the input I need 4 vectors which defines 2 lines, P1, Q1 and P2 and Q2, and the return is an integer, a boolean intersect. No, I'll call it just yes or no, because the function name is do intersect. Okay, so how can I identify whether these 2 lines intersect or not using this function? I need to get the orientation of P1, Q1, P2. So orientation of, I need to call orientation 4 times. P1, Q1 and P2, and the next time P1, Q1 and Q2, and the other time P2, Q2, P2, Q2, P1, right, and P1, and then P2, Q2 and Q1. So I'll promote these results to local variables. I'll call this one O1 O1 and this O2 and this O3 and O4. Right, now now there are 1 2 3 4 and 5 cases. 4 of them are special cases, but I don't want to consider them. I am going to consider only this. Return for the condition this one not equal to this one, to this one, and then this one not equal to O4 and the AND of these two. That's what I have to return. Right, so now we have defined this function and this function, not this function. We have defined only these two intersect function and orientation function, and it has already taken 20 minutes of the time. So I'll stop this episode at this point, and in the next episode I'll show you how to use those functions to determine whether these given points are inside or outside of this polygon defined by this spline. And I'll stop this episode at this point. And this part has been a little bit heavy on mathematics, but I hope you guys are okay with that, because we don't have and I don't know any other way to do that without using those mathematical equations and theories. So if you like to support my work, you can get the membership of my Patreon club. Link would be in the description below. And also I have released a source code of this completed procedural crop field generation blueprint, and feel free to check that. And thanks for watching. See you in the next episode. Goodbye.